The experiments and measurements are usually done in groups of 2 to 3 students. Take 4 aluminium samples each group. Take a clean beaker and add 5 milliliters of acetone and transfer the surface into the beaker for sonication.
Make sure that the mirror side surface is on the top side. Because if the mirror side is bottom, then your surface will get lots of scratches. It happened because of friction between glass and surface. Transfer beaker into sonication bath and set 5 minutes. Successful removal of organic and inorganic particulate contaminants from surfaces. The size is submicron particles. Ultrasonic cleaning is an established method for removing micron-size microcontaminants or larger ones from hard surfaces. Once you have done sonication, then take our beaker from the sonication bath. Dry the surface under a flow of nitrogen or argon flow. You can remove fissile solvents and other contaminations from the surface. Immerse 4-al-2O3 substrates in a freshly prepared mixture of methanol, 1 ml, and 37% hydrochloric acid, 1 ml, in a small beaker for 30 minutes. You will observe the formation of a large number of bubbles. Subsequently, wash the surface with ultra-pure water, and sonicate in 5 ml of water, and finally sonicate in 5 ml of ethanol. Take 20 ml screw-capped glass vial for surface modification. And prepare the surface modification solution, which is 1 millimolar solution of 12-bromo-dodecyl phosphonic acid in absolute ethanol. Transfer those dried surface into a phosphonic acid solution. And make sure that the mirror side facing an upward direction. Then tightly close with cap and solvent didn't evaporate easily. Because next, we are going to heat surface at 60 degrees Celsius. Place the glass vial into a 60 degrees Celsius heated oven for 30 minutes. Then take out from the oven and kept for 16 hours at room temperature. Afterward, the surfaces are rinsed with absolute ethanol. Directly flush the ethanol on the surface. Then dry the surface under a flow of nitrogen or argon flow. If you observed any precipitation on the surface, then perform sonication in ethanol. Finally, surfaces are heated at 100 degrees Celsius under vacuum for 1 hour. Because it requires thermal annealing or curing after deposition of a thin phosphonic acid film, it was proposed that the phosphonic acid molecules in the unheated, as deposited, film are only weakly fissile on the surface. These dried surfaces are stored in a plastic vial with a label properly, because to avoid any dust particle deposition. Then characterization by contact angle and X-ray photoelectron spectroscopy, XPS. Functionalization of this bromo-terminated phosphonate modified aluminum oxide surface. The further surface was reacted with sodium azide to the formation of the azide group for additional click reaction. To obtain the azide terminated on aluminum oxide surface, substrate was immersed in a 0.1 molar sodium azide solution in dry DMF for 16 hours at 60 degrees Celsius under nitrogen or argon in a closed glass vial. Observation: sodium azide no completely soluble in DMF solvent. only after heating it's soluble. Again, surface and reaction mixture is heated in the 60°C oven. The azide modified substrates are rinsed, sonicate in DMF 5 minutes, ethanol 5 minutes, and dichloromethane 5 minutes, and dried in nitrogen or argon flow.